Okay, so we have these are default initialized. Okay, value initialized means whatever the value is default for the int will be zeros and then string will be null and all. Okay, so we have character. um, Character arrays are special. Character arrays are special. Character arrays have an additional form of initialization. We can initialize such arrays from a string literal. Okay, from a string literal like this. When we use this form of initialization, it is important to remember that string literals end with a null character. That null character is copied into the array along with the characters, the literal. Okay, so it does not have no null, and then explicit null, then a null terminator added automatically. Okay. So then as the dimensions of A1 is 3, dimensions of A2 and A3 is both 4, and dimensions this is it cannot fit, right? Error, no space for the null. Okay, so there must be size array hold no copy assignment. Okay, we cannot initialize an array as a copy of another array, nor is it legal to assign one to another. Array of 3 ends, array cannot initialize one array from another and cannot assign one array to another. Some compilers allow array assignment as a compiler extension. It is usually a good idea to avoid using non-standard features. Programs that use such features will not work on different compiler. Understanding complicated array declarations like vectors, arrays can hold objects of most any type. For example, we can have an array of pointers. Because an array is an object, we can define both pointers and references to the array. Okay. Defining arrays that hold pointers is fairly straightforward. Defining a pointer or reference to an array is a bit more complicated. So we have array of pointers, then we cannot have no array of references. This is p array. Okay, this p array points to an array of tangents. Okay, so that's how, like function pointers. Okay. Array points to an array of tangents. Okay, and this is a reference for a tenants. Array AR refers to an array of tenants. Okay. By default, type modifiers bind right to left. Reading the definition of PTRs from right to left is easy. We see that we're defining an array of size 10 named PTRs that holds pointers to ends. Okay. Then reading the definition of P array from right to left isn't as helpful because the array dimension follows the name being declared. It can be easier to read the array declaration from inside out rather than from left to right. Okay. So reading from the inside out makes it much easier to understand the type of P array. Okay, so we start by observing that the parentheses around P array means P array is a pointer. Okay, right? Looking right, we see that P array points to an array of size 10. Looking left, we see that the element in the array are ints. See? Okay. Thus, P array is a pointer to an array of 10 ints. Right? Similarly, says as a reference, the type to which it refers is an array of size 10. Okay. That array holds elements of type int. Of course, there are no limits on how many type modifiers can be used. Okay, so this is array is a reference to an array of 10 pointers. Okay. Reading this declaration from inside out, we see that array is a reference, looking right, uh, of size 10, which refers to an array of size 10. Looking right, left, we can see the element type is pointer to int. This array is a reference to an array of 10 pointers. It can be easier to understand array declarations by starting with the array's name and reading them from inside out. Okay. Then I move on to assuming text size is a function that takes new arguments and returns an int value. Which of the following definitions are illegal? Is a function. Okay, explain why. Okay, assuming text size is a function that takes new argument and returns an int value. Okay, this is illegal. Unsigned, illegal, illegal. This is right. Wait, 4, 8, 8, 3, 11. Right. Okay, no, this is okay, but it can't be a const char. Okay. See, this is okay, but it can't be a const char. Right, because I just saw it here. This list initialization no null. That this is okay. Exactly 11, it's okay. Explicit null. Okay, so variable. Okay, size of array must be a constant or constant expression. Yes, okay, this is a constant expression and this is, it's okay since we are, since it's okay but can't be used as a string since it lacks the null character at the end. What are the values of the following arrays? Okay, what are the values? Okay, see, this is okay, all empty strings, right? We have all zeros, then this is all empty strings because this is an object, this is primitive, undefined values. Okay, list some of the drawbacks of using an array instead of vectors. No, let's say no dynamic size. No dynamic size. And what else? No dynamic size. Some of the drawbacks of using an array instead of a vector. No dynamic size. Right, difficult manipulation. And iteration. What else? Fixed size. Okay, I'll go with fixed size. Iteration. Cannot grow. Fixed size means cannot grow. Difficult manipulation and iteration. And that is all I got. Okay, let me just try this once. This is exercise 3.51. Exercise 3.5.1, and I have this. What are the values in the following arrays? So we'll go with sorry, what is this? 3.28 CPP. I wouldn't need CN and L and string. Okay, so we define a string SA, string array of size 10. This will be always, and we define int array of size 10, and we go within a function, main function. Then we again define SA2 of size 10, and then int IA2 of size 10. Okay, now let me define some functions. Right, display int. I'll take an int array with a size, and can I use range for array? Will it know when to stop? Okay, let's check that. If I use an array, so let's see. Let's display int I. Right. Okay, I want to see this. Okay, so we go 3.28.cpp, which should throw any errors. Right. Okay. So it threw a bunch of errors. Okay. std begin was not declared in the scope. Did you mean std begin? Okay, so I cannot use arrays directly here. Huh. Display int begin was not but I didn't even use begin here, so we cannot std end begin and end. Okay, so it uses, okay, instead of this it uses the right. Okay, so these arrays don't know the begin and end. I might as well provide a size along with it. Should be sti array of I. Let's copy the same thing here. Okay. String array should work now. We display int to few arguments. You are right. So size of IM. Okay. All right. Oh shit. Sorry. IA divided by okay. Because it is the size of whole, right? Divided by size of the first element. That's why I got 0, but then got bunch of right. So all are zeros. Okay. Then we can do the same with this, but it will have garbage value. No, these are all zeros too. Okay, this is new value defined. R was it specified that these are values different? Okay. So I have okay. If we specify dimension, the number of initializers must not. Okay, if we omit dimensions, the compiler infers it from the number of initializers. Okay, if the dimension is greater than the number of initializers, the initializers are used for the first element, and remaining elements are value initialized. Okay. So all here are value initialized. Okay, my bad. I didn't see that. Right. Okay, so these are garbage value as I thought. So SA and then size of SA divided by size of first element. I don't feel like I should use the size of first element since not all string size, but okay, this is time fuck around and find out, you know. We'll see what happens. It should be padded the same for strings. Like if it is a array of strings, it should be padded the same. Okay, so these are all empty strings. Okay, what is the size of string, if I may know that? Okay, 24 bytes. Okay, so they are padded all with 24 bytes. You can fit everything in 24 bytes. If they do these are all empty as I thought. Okay, so all empty, all zeros and undefined values. Okay, we're accessing the element of an array. As with the library vector and string types, we can use a range for on the subscript operator to access elements of an array. As usual, the indices start at 0 for an element of array of 10. Okay, as usual, the indices start at so 0 to 9. Okay, so we can use a range for, right? Okay. When we use a variable to subscript, we can use a range for access an array. When we use a variable to subscript an array, we normally should define the variable to have a type of size t. Size t is a machine specific unsigned type that is guaranteed to be large enough to hold the size of any object in memory. The size t type is defined in the C stdef header, which is the C++ version of the stdef header in C library. With the exception that arrays are fixed size, we use arrays in ways that are similar to how we use vectors. Okay, for example, we can re-implement our grading program here to use an array to hold the cluster counters. Okay. The only obvious difference between this program and the one on page 104 is that the declaration of scores. Okay. 11 buckets, all value initialized to 0. Okay. In this program, scores is an array of unsigned elements. The not so obvious difference is that the subscript operator in this program is the one that is defined as a part of the language. Okay. This operator can be used on operands of array type. The subscript operator used in the program on page 4 was defined by the library vector template and applies to of operands of type vector. As in the case of string or vector, it is best to use a range for when we want to traverse an entire array. For example, we can print the resulting scores as follows. So we have scores and then plus. Okay. So we can use range for local arrays with size definitions. Okay, so for let's say just int I in IA2 I and okay, so I can omit this here and then I can go. There we go. Alright. Right, because the dimension is part of each array type, the system knows how many elements are in score. Using a for range means that we don't have to manage the traversal ourselves. Checking subscript values. As with string and vector, it is up to the programmer to ensure that the subscript value is in range. That is, that the index value is equal to or greater than 0 and less than the size of the array. Okay. Nothing stops a program from stepping across an array boundary except careful attention to detail and thorough testing of the code. Okay. It is possible for programs to compile and execute yet still be fatally wrong. Okay. The most common source of security problems are buffer overflow bugs. Such bugs occur when a program fails to check a subscript and mistakenly uses memory outside the range of an array or similar data structure. We have identified the indexing errors. Okay, we have a array size. Okay, so this is okay, less than we go should be less than. Ix equals Ix. Identify the indexing errors in the code. IA of Ix. Okay, this is array size G. Less than, this should be less than, and I guess we're good. 0. No, not necessary 0. Yeah, right. Okay, should be less than the array size. Write a program to define an array of 10 ints. Give each element the same value as its position in the array. Okay, this is okay. This is okay, or this is easy. So I want to delete a.exe. Then I want to make a directory called exercise 3.5.2. Then I want to change in this directory, and then okay, okay, escape works. Okay, so 3.31.cpp. And that is all right. So write a program to define an array of 10 ints, give each element the same value as its position. Okay, so using std cout and std ender. Okay, so we define integer array size 10, right? All zeros. Hope so. Let me just check. Okay, great. But I should go like this so that it works in both. But I should use the features, right? Okay, so these are all zeros as they are value initialized. But if I don't define this, then they are all garbage values. Okay. Right. So for size ti equals 0, I less than 10, I plus plus, I want to go I of I equals I, and then we can see okay, 0 up to 9. Great. So this is done. This is done. Then copy the array you defined in the previous exercise into another array. Okay, so I have to copy, define, and a copy of 10 integers. Okay, but this is another. Okay, so I want to copy so I want to copy 3.31.cpp to 3.32.cpp, and then I want 3.32.cpp cpp. No. Okay, so I want to copy now, so I'll go I copy, declare an array for copying, but okay, I can just declare it, right? So I copy 10, copy the contents. We can go for size ti equals 0, I less than size, I plus plus. We can simply go I a copy of I equals I of I, and then we can this. So I'll go 3.32.cpp. Okay, size, sorry, right, okay, we got the copy. and rewrite your program to use vectors. Okay, I can go using vectors. So I'll go using vectors and vector of int ivec, right, and it is going to store 10 things, and I can get a reference. No, I can using a reference, but I would have to define an int anyways. So int I equals to 0, I less than 10, or I can go I less than ivec size, but the size operator is its own, so I should really use decal type ivec dot size. It will infer the size I, since size, then I plus plus, then we go I vec of I equals I, and then we can simply vector for copy. We can go vector int I vec copy. I can copy it from ivec like this, and display the vector for I in ivec copy. I can just do this. Same, exactly the same thing, right? Okay. So what happens if we did not initialize the scores in the program on 116? Okay. Then then all the elements will have undefined values slash garbage values. Okay, there we go. Then we have pointers and arrays. In C++, pointers and arrays are closely intertwined. In particular, as we'll see, when we use an array, the compiler ordinarily converts the array to a pointer. Right, okay. Normally we obtain a pointer to an object by using, hold up, okay, normally we obtain a pointer to an object by using the address of operator. Okay, generally speaking, the address of operator may be applied to any object. The elements in an array are objects. When we subscript an array, the result is the object at the location in the array. As with any other object, we can obtain a pointer to an array element by taking the address of that element. The element in an array object. When we subscript an array, the result is the object at that location in the array. Okay. So we have an pointer to a string points to the first element in the nums. Okay. However, arrays have special properties. In most places, when we use an array, the compiler automatically substitutes the pointer to the first element. In most expressions, when we use an object of array type, we are really using a pointer to the first element in that array. Okay. There are various implications on the fact that operations on arrays are often really operation on pointers. Okay. On such implications, one such implication is that when we use an array as an initializer for for a variable defined using auto, the reduced type is a pointer, not an array. Okay. So this is a pointer. Okay, I2 is a pointer that points to the first element in the array. Okay, so we can use auto like this. Really? I82. We use auto like this. I don't really remember. Hold up. It's the auto type specifier. Okay, never did I use auto like that to specify variables. Okay, but okay, if you say so, I believe it. Okay, I do the pointer and we can't assign an int to a pointer. Although I is an array of 10 ints, when we use I as an initializer, the compiler treats the initialization as if we had written this. Now it's clear that I2 has type this. Okay, and this is also worth noting. It is worth noting that this conversion does not happen when we use decal type. Okay, the type returned by decal type is array of 10 ints. Okay, okay. We can't assign integer star. Okay, can't assign an integer pointer. Okay, so we declared p. Okay, we have a pointer p. Assigns the value of I to an element at I3. Okay, it is worth noting it's an array of 10 ints. Alright, so the type defined by declared type I is array of 10 ints. So I can define that this is an array of 10 ints. Okay. Can't assign to an array. Pointers are iterators. Okay, this I equals 42 is a pointer and we can't assign it to an int. Okay, address. Okay. So I2 is a pointer. Star is a star. Okay, and we can't assign an int to a pointer. Can't assign int star to an array. Okay. Can't assign int star to an array. Okay. Pointers are iterators. Pointers that address elements in an array have additional operations beyond those we described here. In particular, pointers to array implements support the same. Okay, sorry. In particular, pointers to array elements support the same operations as iterators on vectors and strings. Okay, for example, we can use the increment operator to move from one element in array to next points to 1. And just as we can use iterators to traverse the elements in an array, we can use pointers to traverse the elements in an array. Of course, to do so, we need to obtain pointers to the first and one past the element. Okay. So this is 10. Pointers just past the element in the array. Okay. As we've seen, we can obtain a pointer to the first element by using the array itself. Right, there we go. Type pointer. Or by taking the address of first element, we can obtain the of the pointer by adding another special property of arrays. We can take the advantage of the non-existing element when past the element of the array. Okay. Pointed to the last element and pointed just past the last element. Here we use the subscript operators to index a non-existing element. ARR has 10 elements, so the last element in ARR is at index position 10. The only thing we can do with this element is to take its address, which we do to initialize E. Like an off the end iterator, an off the end pointer does not point to an element. Okay. Point to an element. Okay. As a result, we may not dereference or increment the of the point, and using this pointer, we can write a loop to print the elements in an array as follows. Okay. Right, the library begin and end functions. Although we can compute the off the end pointer, doing so is error prone. To make it easier and safer to use pointers, the new library includes two functions named begin and end. Okay, these functions act like the similarly named container members. This is error prone. However, arrays are not class types, so these functions are not member functions. Instead, they take argument that is an array. Okay. So begin returns the pointer to the first and end returns the pointer to one past the last element in the given array. These functions are defined in the iterator header. Okay, iterator header. Use begin and end in the example. Okay, it's p star begin, p star end. Well, it's not end and is greater than equals to 0. Again, it is easy to write a loop to process the elements in an array. For example, assuming array is an int that holds int values, we might find the first negative value in ARR as follows. Okay, the first negative. So we start by defining two int pointers named p begin and p end. Position p begin to denote, okay, does p begin and p end would work in functions. I think I have arrays, pointer and arrays, pointer and arrays. So here and I have 4. Right, then we have begin std end. Counts expression this point arithmetic. Okay, let me try trying if begin and end works. Include iterator contains the begin and end functions. Okay. Works on arrays passed into functions. Okay. So void display int array. I don't think it should work, but question set begin with array, and and array. First of all, I just want to see if this will work. So we'll just call the function display int, call it an IA. Showing my theory. I don't think it will work, but well, let's see. Yep. No matching function for int star begin and begin array. Okay, so I can pass a reference. I can pass a reference to array. What do you think? Will that work? I don't think that will work. Yep. Okay. No. Where's the second time I use that? Clear. Okay. Declaration of array as an array of references. Oh, I cannot have an array of references. Yes, right. Okay, so I will pass you will this work? I don't okay. No matching function call for begin this. Okay. Can I pass you a pointer? First I want to clear. Okay. Then no matching function for this. Great. So won't work. Okay. Using begin and end, it is easy to write a loop to process the elements. For example, this. Okay. We start by defining two int pointers named pbegin. Okay. Pbegin and pend. We position pbegin to denote the first element and pend to when past the last element in an array. The while condition uses pend to know whether it is safe to reference pbeg. Okay. If pbeg does point at an element, we dereference it and check whether the underlying element is negative. If so, the condition fails and we exit the loop. If not, we increment the pointer and last. Okay. A pointer when past the end of a built-in array behaves the same way as the iterator returned by the end operation of a vector. In particular, we may not dereference or increment an of the end iterator. And we have pointer arithmetic, but I am almost out of time. Yeah, one more pointer that I think I will do it next time around. Yes, pointer arithmetic. So this is done. Did some exercises and I learned about arrays and pointer to arrays. Arrays are pointers, pointers are iterators. Particular, when we use an array, the compiler ordinarily converts the array to a pointer. Pointer to arrays, reference to arrays, then arrays and pointers, and arrays at iterator and begin, library, begin and end functions. Okay.